Hi, it's Mrs. Pope, and today we're going to talk about arithmetic series. Our goal is to find the partial sum of an arithmetic series, and the vocab here, series, is when the terms of a sequence are added together. So we're going to be looking for the first however many terms, maybe add up the first 5 terms, or 6 terms, or 10 terms. And a partial sum is the sum of the first n terms. That's what we're going to be looking for. So sometimes we may not want to add up all the numbers in a sequence, maybe just the first few. So the key concept here is, given a1 and an, the sum s sub n is equal to n times a sub 1 plus a sub n divided by 2. So that means the sum of the first however many terms is equal to that number of terms, whatever that is, those n's are the same, times the first term plus the last term divided by 2. So let's see how this works. For example 1, find the sum of this series or sequence, 12, 19, 26, whatever's in the middle, all the way to 180. So if we have our formula here, s sub n is equal to n times a1 plus a n over 2, let's get the pieces that we need and go from there. So we have a1, the first term we know is 12. An, well, we know it ends, that's the last term, so we have that, it's 180. And n, we don't know n. That's something that we're missing, that's something we need to figure out. Well, from before, we know we do have a formula where we can find n. So before we can go any further, we need n, otherwise we're not going to be able to figure it out. We need to know how many terms, how many are in between here. So if you remember from before, a sub n is equal to a sub 1 plus n minus 1 times d. This is the explicit formula for an arithmetic sequence. So a sub n is equal to, where is it, a sub 1, 12, plus n minus 1. And you can figure out what d is. To go from 12 to 19, we add 7. 19 to 26, we add 7. So I know that my d is 7. So a sub n is equal to 12 plus 7n minus 7. And notice, I know what a sub n is. It's the last term. So I can plug in 180. 180 is equal to 12 minus 7 is going to be 5. So 7n plus 5. If I subtract 5 from both sides, 175 is equal to 7n. Divide by 7, divide by 7, n is equal to 25. So now I have my n, which means I can use my formula now. So the sum of the first 25 numbers is equal to 25 times 12 plus 180 all over 2. If you add all of that up and do your order of operations correctly, take a moment and do that, you should end up with 2400. All right. Let's look at example 2. Example 2. Find the first 3 terms. So now we want to find the first 3 terms in a series, in a sequence. So we have A1, we have the first term, we have the last term, and we have the sum of all of the terms. But we don't know how many terms there are, and we don't know how they change. So the first thing we're going to do is find n. Let's figure out how many terms are in this sequence. Then we're going to find d. How are they changing by? What are they being added by? What's being added each time? Then we're going to use d and do that with the first term and be able to get the rest of the terms. So we have our information here. Of course, we're going to use s sub n is equal to n times a1 plus an over 2. Because we have sn, an, a1. So we have most of this. We just need to find n. And we're going to put everything in, because we have everything but in, and figure out what that is. So s sub n is 430 is equal to n times 7 plus 79 over 2. Right? So if you simplify that, you'll have 430 is equal to 43n divide by 43, divide by 43, and you'll see that n is equal to 10. So now we know that there are 10 terms in this sequence. It's going to help us a little bit. And let's figure out what, we want to figure out the first 3 terms. So now that we know that n is 10, we can use our explicit formula to figure out what d is. So we can use a sub 1. Let's see, we're done here. Now we want to find, we found n, we want to find d. So we're done with this, now we're here. So we want to use a sub n is equal to a sub 1 plus n minus 1 times d, because now I have all of these and I can find d. So a sub n is, which one are we going to use? 79. 79 is equal to 7 plus n, oops, I know what n is. We just figured n out. 10. 10 minus 1 times d. Now I have everything but d. So 79 is equal to 7 plus 9d. And if you solve that all out, you'll end up with d being equal to 8. Subtract 75 by 9. You'll end up with d being equal to 8. So now we know what d is, and we know what a1 is, so we know how it changes. So let's just do that. We know that it starts with 7, and my d is 8, so I need to add 8. So if I add 8, I'm going to get 15. And if I add 8 again, I'm going to get 23. So now I've found the first 3 terms. All right, last thing for today, we have a key concept. This is called sigma notation with the sigma, Greek letter, and it's shorthand for finding the sum of a series. So instead of writing out, find the sum of the series, this is shorthand. When you see this, you'll have something at the bottom. This is the starting term. They'll tell you I want to find however many terms, starting with this term, ending with this term. And this will be the formula that you would use to find out what the terms are. So let's look at an example. So here we have find the sum of the 4th through the 18th term when the formula to find the sums is 6k minus 1. So first we need to figure out how many terms there are. So from 4 to 18, we want to figure out how many terms there are. Well, one way you could do it is say 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And you could do that if you want to count it up. Or you could just take 18 minus 4 plus 1. So 18 minus 4 would be 14, and then plus 1 would be 15. And you may be asking, why am I adding 1? If I just take 18 minus 4, that's just the difference between them. But remember, I actually need to use 4. So that's like saying 4, 5, 6, 7, 8, 9, all the way up to 18. So keep that in mind. So I know that there are 15 terms. So now, if I were doing this by hand, I want to use the sum formula. But what this really means is you want to plug in 4, figure out that number, add it up. Plug in. So here, let's just do a few examples. So what this really means is plug in 4. 6 times 4 minus 1. That's one term. Plus the next term. 6 times 5 minus 1. Plus 6 times 6. Oops. 6 times 6 minus 1. 7 times 6 minus 1. Just keep going and going and going and going all the way until you get to 18. That would take a really long time to write out. So with this sigma notation, we can just use our sum formula. So we can use the sum of the first 15 terms, which is what we're looking for because there's 15 terms here. So the sum of the first 15 terms, remember that's equal to 15 times A1. And let's figure out A1. 24 minus 1 is 23. Right? So that would be 23. And let's figure out the last term. Let's just plug in 18. So dot, 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 dot. So we got down here 6 times 18 minus 1. If you figure that out, it's going to be 107. So plus 107, all divided by 2. And I just pulled this formula from before. So if you figure all of this out, take a moment, calculate it, and you should end up with 975. So what I did was using this, instead of writing all of these out and adding them up, I can use this information. I can find using, I found n, subtract these two, add 1. That was my n. To find the first term, I just calculated it. Find the last term, I plugged in 4. Find the last term, I plugged in 18. And then I just plugged everything else in and solved. Thanks for watching, and remember, you are responsible for your own learning.